Everyone, my name is Ruby Gunalan, and today I'm going to present problem-based tasks for subject network security. So this is the PBT question that they given. Okay, so in section A, okay, these are the objectives for section A. Use syslog to capture log files from multiple network devices. Observe AAA user access logging. Observe net flow information. Okay, for the section A, the required sources is packet tracer 8002, packet tracer file lab 5.2. Okay, so this is the packet tracer file that we needed for this section A. Okay, and this is the instruction for this packet tracer. In part 1, okay, step 1, syslog is a messaging system designed to support remote logging. Syslog lines and send log entries to a syslog server. The syslog server concentrates and stores log entries. Packet tracer support basic syslog operations can be used for demonstration. The network includes a syslog server and syslog clients. R1, R2 core switch and the firewall are syslog clients. These devices are configured to send their log entries to the syslog server. The syslog server collects the log entries and allows them to be read. Log entries are categorized by 7 severity levels. Lower levels represent more serious events. The levels are emergencies, alerts, critical errors, warnings, notification, informational, debugging. Okay, syslog clients can be configured to ship log entries to syslog servers based on the severity level. Okay, in A, click the syslog server to open it window. Okay, so I click it here, the syslog server. Then select the services tab and then select syslog from the list of the services shown on the left. Click on to turn on the syslog service. Okay, I turn it on. Then syslog entry is coming from syslog lines and will be shown in the window on the right. Currently, there is no entries. As we can see here, there is no entry for now. Okay, keep this window open and visible and move on to step 2. Okay, I just minimize it first. Okay, then in step 2, okay, enable syslog. The devices are already configured to send log messages to the syslog server, but packet tracer only support the logging for the debugging severity level with syslog. Because of that, we must generate debug level message level 7 so they can be sent to the syslog server. Okay, click R1, CLI tab. Okay, we go to R1, I click it. Okay, so I click it, then, okay, then press, okay, we have to go to CLI. Okay, then press enter to get a command prompt and enter the command enable. Okay, then enter the command debug ergrp package. Okay, debug ergrp package. To enable ERGP debugging, the command line console will immediately fill with the debug messages. Okay, I click enter. Then it shows ERGP package debugging is on. Update request query reply hello ACK. Okay, we can see here. Then return to the syslog server window. Verify the log entry appear on the syslog. Okay, so now we go to the syslog. Okay, we can see here there is a syslog server. Okay, there's a lot of entry here. We can see it. Okay, then after a few messages have been logged, click the ratio button to turn the syslog service off. Okay, now we have to click the off button. Okay, then what is some of the information that is included in the syslog messages that are being displayed by the syslog server? Okay, Okay, as we can see here, okay, the information is the time. Okay, we can see the time here, and then the host name, and then the messages, which is ERGIP, receive hello on gigabit internet 0/1 with host name, address, and then they have a ERGP receive hello and ERP sending hello. So these are the information that we can see here. Then okay, so now we can close the R1 device window. Okay, now we can close this. Okay, next is part 2. Okay, log user access. Another important type of log relates to user access. Having records of user logging is crucial for troubleshooting and traffic analysis. Cisco IS support authentication, authorization, and accounting AAA. With AAA it is possible not only to delegate the user validation to task and external server, but also to log activity. TACACS Plus is a protocol designed to allow remote authentication through a centralized server. Packet Tracer offers basic AAA and TACACS Plus support. R2 is also configured as a TACACS Plus server. R2 will ask the server if that user is valid by verifying username and password, and grant or deny access based on the response. The server stores user credentials, and it's also able to log user login transaction. Follow the steps. Okay, we have to follow the step below to log in to R2 and display the log entries related to the login. Okay, first one is we have to click the syslog. Okay. Then select the desktop tab and then select AA accounting. Okay, here we can see the AA accounting. We have to select this and leave this window open. Okay, so we just leave it this like this, and then okay, click R2. Okay, now we have to click R2. Okay. Then press, okay, we have to go to CLI. Okay, press enter to get prompt. Okay, R2 will ask username and password before granting access to its CLI. Enter the following user credentials, which is the username is analyst. Okay, we have to give analyst. Okay, the password will be cyber oops. Okay, so we can see it. Okay, return to the syslog server accounting records window. Okay, now we have to return to this. Okay, here we can see it. Okay, then what information is in the log entry? Okay, we can see here the log entry is they have a date UTC December 30, 2021. Okay, they provided the date we are get in. The username that we enter is analyst, the caller ID. Okay, the flag is started. Okay, we just started it. Okay, the NAS IP is 192.168.12.2. Okay, and then we also can see next port is called O. Okay, next is on R2, enter the logout command. Okay, so we have to go to the R2. Okay, then we click log out. Okay. Then what happened in AA accounting window? Okay, now we go to the accounting window. Okay, here we can see that it shows the time that we are logged out, the date and time, which is 22 and 57 minutes and 01 second, and the UTC December 30, 2021, the date, and then the username is analyst and the caller ID The flag is shows stop. Okay, the previously is shows start, and now once we log out, it shows stop. And AS IP is same as the previous, and then the next port also same as previous. Okay, next is on part 3. Okay, part 3, NetFlow and visualization. In the topology, the syslog server is also a NetFlow collector. The firewall is configured as a NetFlow exporter. Okay, click the syslog server to bring up its window. Close the AA records window. Okay, so now we go into syslog server and we now close the AA accounting records. Okay, then from the desktop tab, select NetFlow collector. Okay, now we have to search for the NetFlow collector. Okay, here we can see here the NetFlow collector. Okay, the NetFlow should be turned on. Okay, as we can see here, it's turned on. From any PC, ping the core web server at 209.165.200.194. After a brief delay, the pie chart will update to show the new traffic flow. Okay, okay, now we have to ping into any PC. Okay, just copy it first. Okay, just minimize it first. Then I'll go to the PC 2.2. Okay, desktop command prompt. Okay, I'm going to ping here. Okay, ping. Okay, let's see the. Okay, which is ping 209.165.200.194. Okay, enter. Okay, we wait for the reply. Now we can see here just only 2 of these we getting the replies. So we try once again. Okay, now we can see all of these started to getting reply, and then okay, it's 100% successful. Okay, then okay, after that, after a brief delay, the pie chart will update to show the new traffic flow. Okay, now we go to the syslog server net flow collector. Okay, now we can see here the information that the pie chart is already updated. Okay, okay, note. The pie chart display will vary based on the traffic on the network. Other packet flows such as ARGP related traffic are being sent between devices. NetFlow is capturing this packet and exporting statics to the NetFlow collector. The longer NetFlow is allowed to run on a network, the more traffic statics will be captured. Okay. Now we have to go to the PC 2.2. We type ipconfig to see the IPv4 address. Okay, we can see here the IPv4 address is 192.168.12.19. So let's see in the NetFlow collector. Okay, which one is the same IP address? Okay, this. Okay, IPv4 source address. Okay, we can see the. Okay, we can see the traffic contribution is 1.25%. Okay, the IPv4 address is 192.168.12.19. Okay, the IPv destination is 209.165.200.194. Okay, the interface input is gigabit 0/1. Okay, and all other information that we get it from the PC 2.2. Okay. Okay, so we're done with the section A. Now we go to the section B. Okay, so this is the section B. Okay, in this section B, the objective is create FTP traffic, investigate the FTP traffic, view syslog messages. Okay, then for the section B, the required sources is packet tracer 8002, packet tracer file from lab 5.3. Okay, so this is the um, lab 5.3. Okay, then and this is the instruction for this packet tracer, and then they given the addressing table. Okay, so let's move to the part 1. Create FTP traffic. Okay, step 1, activate the sniffing device. Click on the sniffer device sniffer 1. Okay, so click on the sniffer 1. Okay, then go to the physical tab. Okay, we are in physical tab. Turn on the power to the sniffer. Okay, so if we zoom in, now we turn on this. Go to the GUI tab and turn the sniffer service on. Okay, so we go to the GUI and then sniffer service on. Okay, the sniffer service is already on. Okay, then the FTP and syslog packets entering the sniffer from router 2 are being monitored. So anything that enter to sniffer from router 2 is now monitoring here. Okay, then next is step 2. Remotely connected to the FTP server. Click on PCB and go to the desktop. Okay, now PCB. Okay, and go to the desktop. Okay, then click command prompt. From the command prompt, open the FTP session with STP server. Okay, we have to type FTP underscore server using its public address. Help with the command line is available by typing at the prompt. Okay. Now we have to use the public IP address. So we go to the table that they given. Okay, we can see the FTP server, private address, and public address. So we're going to use this one, public address. Okay, so 209.165.200.227. Okay, enter. Wait a while. First of all, we have to have if the command line is available by question mark. Okay, then we can see here the FTP. Okay, now we can type FTP underscore server. We can see we can use the previous command. Sorry, the command is wrong. It's supposed to be FTP and then 209.165.100.227. Enter. Okay, it's trying to connect. Okay, connected to. Okay, so it shows welcome to the PT FTP server. Okay, and it asks for the username. Okay, let's see the next question. Enter the username of Cisco and the password is Cisco to authenticate with the FTP server. Okay, so the username and password is same, which is Cisco. Okay, last for the password, Cisco2. Okay, logged in passive mode on FTP. So we are successfully entered into the FTP. server. Okay, next is step 3. Upload a file to the FTP server. At the FTP prompt, enter the command dir to view the current file stored on the remote FTP server. Okay, so now we have to type dir. Okay, so we can see the current files are stored in the remote FTP server. Okay, so then next is upload the client info.txt file on the FTP server by entering the command put client info.txt. Okay, so now we have to enter the command put client info.txt. Okay, then enter. Okay, writing file client info. Okay, okay, so successfully waiting the file. Okay, file transfer in progress, then file transfer complete. Okay, the bytes copy in 0.33 seconds, which is 1952 bytes. Okay, the next is at the FTP prompt, enter the command dir and verify that the client info.txt file is now on the FTP server. Okay, now we are going to check whether the client info.txt file is still on the server or not. Okay, so dir is taking time to listing. Okay, so now we can see here. Okay, now we can see here the client for txt is on server, on FTP server, because of we are already inserted. Okay, next is enter quiet at the FTP prompt to close the section. Okay, to close the section, we have to type the command quiet. Okay, so service closing control connection, so it's successfully closed. Okay, next is part 2. Part 2, investigate the FTP traffic. Click the sniffer 1 device. Then click the GUI tab. Okay, now we close this one. Okay, we click sniffer 1. Then GUI, we are already in this. Okay, then next is click through some of the first packet in the section. Be sure to scroll down to view the applications layer protocol information in the packet detail for each. This assume this is your first FTP section. If you have opened the other section, clear the window and repeat the login and the file transfer process. This first one. Okay, now we can see here the FTP is come on. Okay. Okay, so what is the security vulnerability presented by the FTP? Okay, now we can see here the security vulnerability is okay, FTP command is the user, FTP user, and the FTP argument is Cisco. Okay, if we click on the next FTP is okay, the security vulnerability is asked for the which is password and Cisco. So here we can see the if we ask for the username and password. Okay, next is what should be done to mitigate the this vulnerability. Okay. Okay, for this one, we will use a secure file transfer, which is protocols such as SFTP. Okay, so next is part 3, view syslog messages. Okay, step 1, remotely connected to router 1 from the PCB command line, telnet to router 2. Okay. Now we have to go to the PCB. Okay, command prompt. Okay, so okay, they ask for the telnet to the router 2. Okay, so we have to go and look forward to the table router 2. Okay, now we have gonna SSH -L admin then 209.165.200.226 enter. Okay, then is trying to connecting. Now we have to the command is telnet. We use the same public IP address, which is 209.165.200.226. Enter. Okay, it's trying to access. Okay, user access verification. Okay, they ask for the username. Okay, we back to the question. Okay, use the username admin and the password Cisco for authentication. Okay, so the username is admin and then the password is Cisco. Okay, so we successfully enter it and then enter the following commands at the router prompt. Okay, so now we have to type this command debug IPRCMP, enter. We can see the ICMP packet debugging is on. Okay, so next is type logout at the prompt to close the telnet session. Okay, so now we to type the command logout. Okay. Okay, connection to closed by the foreign host. Okay, next we go to the step 2. Okay, generate and view the syslog messages. Click on the syslog server device and go to the services tab. Okay, so now we have to click the syslog server here. Then go to the services. After that, click the syslog service. Okay, verify that the service is on. Okay, yeah, it is on. Syslog messages will appear here. Okay. Okay. So it is empty. Okay, next is go to the host PCB and open the desktop tab. Okay, we just aside this one first. Okay, now we have to go to the PCB. Okay, then we have to go to the desktop. Okay, then open the command prompt and then ping router 2. Okay, now we have to ping the router 2 address. So we go to the table first. Okay, we have to ping this public address here. Okay, ping 209.165.200.226. Enter. Okay, it's getting the reply. Okay. Okay, we can see here it's successful, 100% success getting the reply. Okay, then go to the host PCA and open the desktop. Okay, now we go to the PCA. and then desktop. Okay, go to the command prompt and ping router 2. Okay, so here also we have to ping the router 2 address, which is 209.165.200.226. So here also we are getting the replies. Okay, then on the syslog server, investigate the logged message. Okay, now we ping both of these PC A and PC B. So now we go to the syslog. Okay, so here we can see that they have a log message. There should be 4 messages from PC A and 4 PCs B. Okay, it's totally have 8 messages. So okay, which is 4 messages from PC A and 4 messages from PC B. Can you tell which echo replies are from PC A and PC B destination addresses? Explain. Okay. Now we can both of the PC A and PC B have the same destination address because NAT, which is NAT, is translating internal private addresses to internal public addresses. So we can see that the host name is fails to verify the device in the syslog. Okay. So next is ping router 2 from PCC. Okay. The PCC. Okay. Desktop command prompt. Okay. Okay, we're gonna pin the router 2 here. Okay, so here we can see that we're getting the replies. Okay. So now we go to the syslog, verify it. Okay. Okay, here we can see that the question. Okay. Okay, what will the destination address for the replies be? Okay, so we can see the destination is changed. The IP address is destination IP address will be the internal private address for the PCC. Okay. So that's all from me. Okay, thank you.